Hi everyone, great to see you. The first probability that we will calculate is a probability that two natural numbers, a and b, are coprime. That means the GCD is equal to 1. Let's give a first example. We calculate the GCD by factoring the two numbers into prime factors, and we see which prime factors they have in common, and that is the GCD. So, a and b are just natural numbers. The first question we can ask is, what is the probability that a prime p divides a? Probability that p divides a. Now, if you think logically about this, of p consecutive integers, 1 will be a multiple of p. So this is equal to 1 over p. And the same for b. The probability that p divides b, with p a prime, is also 1 over p. So this gives us that the probability that p divides a and p divides b is equal to 1 over p squared. Now notice that this is exactly what we don't want to happen, since we want that the GCD is 1. So the probability that this doesn't happen is not p divides a and p divides b, is equal to 1 minus 1 over p squared, which I will write as 1 minus p to the minus 2. Now, of course, this doesn't need to happen for one prime, but for all the primes. So the probability that we are searching, let's call this p of star, is the product over all primes, p prime of 1 minus p to the minus 2. Well, you might think, how on earth are we going to calculate this? Well, there's a neat trick which is called Euler's product formula, which is one of my favorite formula in mathematics. So let me clear the board and write that down. Now this is the Euler product formula. It gives two ways to represent the very famous Riemann Zeta function, zeta of s. One way as a sum of all integers, 1 over n to the s, and one way is a product over all the primes, p. So this gives a connection between the natural numbers and the primes via this formula. Now this yields for all s in C with real part of s bigger than 1, but we will only need this case, which is n is equal to 2, or s is equal to 2. So let's write down what we need. We need zeta of 2, which is this infinite sum, 1 over n squared, and it is equal to this product over primes, one over 1 minus p to the minus 2. Now look at this. We have almost the same. We have just the inverse. So this is equal to 1 over the probability that we want, which is this probability. So what we actually need to solve for is P of star, which is 1 over the Riemann Zeta function of 2. So if we are able to calculate the Riemann Zeta function of 2, then we have our desired probability. But first, let me prove this beautiful result. Now from this video, and go all watch that video, we know that the following sum over all of the odd integers is equal to pi squared over 8. Now notice that this looks similar to the zeta of 2 value, but we also need the even values. So let's call this S. Now we know that zeta of 2 is S plus the even values, which is 1 over 2 squared times zeta of 2 itself. But now we can solve for zeta of 2. So this represents the even integer. So zeta of 2 times 3 over 4, if we do this to this, is equal to S, which is pi squared over 8. And this tells us that zeta of 2 is equal to pi squared over 6, which means that our probability star is 1 over zeta of 2, which is 6 over pi squared. So the probability that two random natural numbers are coprime, which means they have GCD 1, is exactly equal to 6 divided by pi squared. Let's now go to the second crazy probability. Now the second probability is about rounding fractions. With such probability suggests if we round y over x, it is even. So let's give some examples. Round of this is 0, and of this is 8. If it would be exactly 7.5, that doesn't matter because that's probability 0. So we can represent this in a grid. with x on the x-axis and y on the y-axis, and points between 0 and 1. Now, let's first look at the probability that round of y over x is exactly 0. Now that means that 0 is less than y over x is less than 1/2. Now this means that y is less than x over 2. And now we can draw the area that this will represent in the grid. This will be this point 1/2, y equals 1/2, and this will correspond to this area where y is less than x over 2. Now this area is just equal to 1 over 4. So this probability is equal to 1 over 4. Let's now use a second example where we calculate the probability that round of y over x is equal to 2. Now that means that y over x is between 3 over 2 and 5 over 2, which gives us that y is between 3 over 2x and 5 over 2x. Now if we will graph this, then these points will have x equals 2/3 and x equals 2/5. And now we need the area of this triangle. Now the area of that triangle is just the base times the height divided by 2, which is 2 over 3 minus 2 over 5 over 2 times 1. So this is equal to 1 over 3 minus 1 over 5. Now for the third example, if we calculate the probability that round of y over x is exactly 4, we will get the same situation, but with the fractions 7 over 2 and 9 over 2. So this will mean that here x will be 2 over 7, and here x will be 2 over 9. Now if we calculate the same area of that new triangle, a yellow triangle then it will be 1 over 7 minus 1 over 9. So let's now clear the board and write that pattern down. So what we have established is that we can write this probability as a sum of all these individual probabilities. It's an infinite sum, actually. And this was equal to 1 over 4 plus this one was 1 over 3 minus 1 over 5 That one was 1 over 7 minus 1 over 9. And this pattern keeps repeating. 11 minus 1 over 30. Now if we calculate the brackets, we can just remove them to get this. 3 minus 1 over 5 plus 1 over 7 minus 1 over 9, and so on. Well, now we will use the Taylor expansion of the arctan of x, which is the following. If we evaluate this as x equals 1, then we get the following equality: pi over 4 equals 1 minus 1 over 3 plus 1 over 5 minus 1 over 7, and so on. We can now use this in our sum, because this is equal to 1 over 4 plus, and this part we can replace by 1 minus pi over 4 if we put all this to the other side. So this is plus 1 minus pi over 4. Let's now calculate this out. This is equal to 1 over 4 plus 4 over 4 minus pi over 4, which is equal to 5 minus pi over 4. Another really surprising result. So we conclude that if we choose a and b arbitrary natural numbers, that the probability that GCD of a and b is 1 is equal to 6 over pi squared, and that round of y over x is even, that probability is 5 minus pi over 4. Somehow pi ends up in both these probabilities. If you watched till the end, thanks for listening. Don't forget to like and subscribe.